Good morning, everyone. My name is Greg. I'll be talking about a project called Academy, which has maybe been mentioned in a couple presentations at this point at Parcel Fest. This project started this winter as a part of my dissertation, but now that I've graduated and started a new job, this project is still being worked on by all the other people that you see on the screen here. So let's get into it. What is Academy? Well, Academy is our prototype for building multi-agent systems across federated research infrastructure. We call it an agentic middleware, which means it's a software layer that transparently manages the lifecycle, communication, and coordination of autonomous agents across distributed computing environments. And we're particularly interested in supporting federated resources, so the ability to run agents through simple agent abstractions across your compute resources, your experimental facilities, and your data storage. Now, you've also probably heard agents as a term used to refer to a whole bunch of different things. So I actually want to start with a little bit of context about where Academy fits in the world. When we think about the different middlewares that allow us to build agentic systems, there's a lot of interesting scopes and challenges to be addressed, from low-level things like actually deploying the agents on your resources, like HPC systems, all the way up to high-level things like how do you interact with LLMs to build multi-agent conversations. And popular frameworks like LangChain, AutoGen, Pydantic AI, I think they're really focused on these higher level challenges and kind of starting to work down. As you heard how Chen talk about, a big thing right now is working on protocols for agents to interact with each other. But with Academy, we're really more interested in these lower level challenges. Like, how do we actually get agents onto our research infrastructure? And hopefully, we'll work our way up and meet in the middle and be able to do some cool science. But I want to focus more on this problem of like, how do we actually use the research infrastructure? And there's a few different ways that you can think about how to do this. The first is the centralized approach, where you have agents that are co-located, say, on a workstation or a cloud node. And then your research infrastructure is made available to you via APIs. You can refer back to what Hao Chen introduced about using MCP servers as ways to interact with your research infrastructure. And then agents can use these via tool calling. And there's a very rapidly growing ecosystem of libraries that allow you to do this. But sometimes the problem is that we just have limited APIs for our research infrastructure, so we can't really do this in the first place. And this is kind of the view that LangChain, AutoGen, Pydantic AI want you to take when building out agentic systems. But we're more interested in this decentralized approach, where you take your agents and you distribute them across your research infrastructure. Those agents interact with each other asynchronously, but they use the infrastructure directly. So you have an agent that lives on a robot that actuates that robot directly, or one that lives on a login node and submits jobs directly to a scheduler. This is great for data locality, performance, loose coupling, but it comes at the cost of much greater deployment complexity. And this is what we're interested in solving through Academy. So I'll get into the design real quickly. There are three focuses in the design of Academy. The first one is how do we program diverse agents and their interactions? We really want to support building any kind of agent that one could imagine. And we do this through these very simple agent primitives. So in your Academy application, you'll have two kinds of entities, users and agents. A user is just any Python process that has a handle to a running agent and is going to interact with that agent. And then agents are defined by some set of actions that they can perform on behalf of others, a set of control loops that define the autonomous behavior of the agent, possibly handles to other agents to kind of enable multi-agent interaction, and then of course, very importantly, some local state that changes how the agent is doing things and evolving over time. The second focus is we want to be able to deploy these agents across federated resources. We do this through these executor plugins, and I'll talk more about that in a second. And the third focus, and kind of the hardest one, is how do you coordinate asynchronous messaging between all these different agents? So we take this mailbox model where we have an exchange that hosts a mailbox for every entity in your application, and then those entities interact by sending each other request messages to mailboxes, reading those messages, responding to the other person's mailbox. And currently, you can deploy your own exchange, but in the future, we're working towards a hosted service, kind of like the Globus Compute model, so anyone can kind of use this publicly hosted exchange to build their applications. And then on the executor side, you can use a whole bunch of different types of executors. You can even just run the agents directly yourself in like a Python script. But of course, in the paper preprint that we have online, we put a lot of emphasis on using Globus Compute for federated execution and Parcel for distributed across clusters. Here's a brief example of how you might actually write one of these agents as code. They're defined by a class, so any instance of this class is an agent that embodies the local state of that agent. And you can define methods, you can decorate them to be actions that other people can request this agent to perform on their behalf, as well as control loops that run for the lifetime of the agent, controlling its autonomous behavior. And then once you've written your agent, you can launch it. There's a number of different ways you can do this, but the easiest way to get started is via this manager interface that manages the exchange that all the agents and users are going to be connected to, as well as the different executors you're going to use for executing the agents. In this example here, we're using a Globus compute executor, and we can launch an agent on that executor and then get back a handle. And this handle allows us to asynchronously interact with that agent. These handles are also really powerful. You can pass them around to other agents and other entities to kind of build more sophisticated applications and multi-agent interactions. So with the last minute or so that I have, I'm just going to tease one application. This is also probably an application that people have mentioned at this point already at ParcelFest. This is called MOFA. Really interesting application because of kind of the complexity of the steering code. And so what we did was we took the steering code of MOFA and we rewrote it in 6 different agents in Academy. And then we could deploy these agents across different resources that were best fit for the tasks that those agents were going to do. So we have 2 agents that run on login nodes of Aurora, and they actually scale up and down their resources based on their local workload. Similarly, we have another agent that runs on Polaris, doing some other simulations. And then we have a bunch more agents that live up in Chameleon Cloud, either because we care most about availability or fast single core performance for the tasks that they need to do. And then all these agents are executed via Globus Compute, so you can launch them, sit back, and actually watch these agents autonomously carry out this workflow. I'm not going to dig into the details of this trace here, but it basically shows you how the agents slowly spin up over time when they get work to do from other agents, and how they also scale up and down their resources on the batch systems based on their local demand. So why is this better? A few reasons. Placement, we can move agents to resources that make most sense for them. Separation of concerns, we can do resource acquisition and scaling based on their local workload. Loose coupling between agents so we can swap them out or integrate new agents over time. And last, we want to work towards shared agents, where you can share multiple different agents between different workflows in a microservice-like architecture. So I'll wrap up there and take any questions. I want to shout a few things out. We have a whole bunch of information online on GitHub, our docs, our preprint. Please reach out if you're interested. But most importantly, we have a tutorial going on at SC25 this year. That'll be Sunday morning. So please attend if you want to get hands-on with Academy.